Okay, guys, this is part 2 for section 4.3. Before we get started, there was an example at the end of part 1 of the notes that we were talking about reference angles. I know some of you guys have heard of reference angles before, but I'm not sure that all of you really understand what they are. So let me just briefly go over the definition of a reference angle. It's an acute angle. It always has to be acute, formed by the terminal side and the x-axis. Okay? And really what it is depending on how far past the x-axis you go or how short of the x-axis you go, that will determine what the reference angle is. Two examples down here. You have a 240 degree angle. Okay? Now 240, that's going to land you in the third quadrant because remember, that gets you to 180. Okay? And then obviously, it's not going to get you another 90 degrees to 270, so you're going to stop in here. So we passed the x-axis. Now the question is, how many degrees did we go past the x-axis? Well, if the negative x-axis here is 180, then that means we went 60 degrees past. That makes 60 degrees our reference angle. Okay? Now, degrees obviously is easier than radians. If you do have a radians problem, okay, if you have something like 3 pi over 4, now, you know, a lot of people will say, well, I don't know, like, how do I know what quadrant I'm in with 3 pi over 4? Well, think of it this way. This is another way of saying 3/4 pi, okay? Now, what that means is that you are short of 1 pi. And if you remember, pi is 180 degrees. 2 pi is 360. Okay? So you're short 1 pi. So as you can see, your angle is going to wind up in the second quadrant. Now we stopped short of the x-axis. We didn't go past it this time. We stopped short of it. Well, what does that mean? That means that how many pi over 4s do I need to get so that this will get to 1 pi? And that is pi over 4. So this pi over 4 would be the reference angle here. Guys, really what we're trying to do is we want these reference angles to be 30. That's a 3. 45. 60. Okay? Because what that's going to do is that's going to allow us to figure out the sine, cosine, and tangent of the larger angles based off of what the sine, cosine, or tangent is of the reference angle. That's what I was trying to get at with that last example from part 1. So if we go back, okay, to example 5, it asks us to find the following without a calculator. Now, sine of negative 210. Now you can see here that I've already drawn in 210. Okay, negative 210, excuse me. Negative 210, remember negative direction is clockwise on the coordinate plane. So negative 210 actually goes past the x-axis. Now how far does it go past? It goes past 30 degrees. Okay? Alright, so our reference angle is 30 degrees. Now, one other thing that I kind of mentioned in example 4 in part 1, but I want to reiterate here. Okay? When you're trying to figure out sine, cosine, and tangent, okay, and you're looking at what quadrant the terminal side is in, here's what you need to look for. Okay? In quadrant 1, everything's positive. Sine, cosine, tan are all positive. Okay? In quadrant 2, sine is positive, cosine and tangent are negative. And the reason why is because in the second quadrant the x-coordinate is, or the x's are negative. In the third quadrant, okay, sine, cosine are negative, but tangent is positive. The reason tangent's positive is because both sine and cosine are negative. Okay, negative divided by negative is positive. In quadrant 4, okay, sine, oh, that's my laundry, sorry. Sine is negative. Actually, one moment. I'm not going to fold my laundry. Not yet, anyway. The sine and tangent are negative, and cosine is positive. Okay? If you want to think of it this way, All right, if you want to think of it this way, whoops, cosine sine would be the ordered pair that corresponds to xy. So wherever your x's are negative, your cosines are going to be negative. Wherever your y's are negative, that's going to mean your sine is negative. Okay? And then tangent is really sine over cosine. Okay? So let's get back to the problem. So the sine of negative 210, okay, is the sine of the reference angle, which is 30 degrees. Okay? So we can take the sine of 30 degrees, and that will be the same as the sine of negative 210. Well, what's the sine of 30 degrees? If you remember back to your special right triangles, okay? Remember back to your special right triangles now. The sine of 30 is 1/2. Okay? So what we're doing is we're just finding a reference angle, or the reference angle, taking the sine of it. Okay, remember we're in quadrant 2, so that means the sine is positive. Okay, that's why I got a positive 1/2 instead of a negative. Now example 2 talks about finding the tangent of 5 pi over 3. So let's erase some of this. Now, as you're kind of preparing to do this, think about what quadrant 5 pi over 3 is. Okay? Now, if you're having trouble figuring out what quadrant it's in, think about this. 5/3 is slightly less than what whole number? Okay? So the answer is 2 pi. So it's just short of 1 whole revolution around. Okay? So we have to stop, okay, in the 4th quadrant. Now, the question is, what's the reference angle? In other words, we are short of the positive x-axis. The question is this: how many pi over 3's do we have to go? Well, to go from 5 pi over 3 to 2 pi is only 1 more pi over 3. Oh, I got a text from my Uncle Tom. He's my godfather. Good dude. Okay? Oh, interesting. Anyway, we always talk about cell phones being a distraction. Anyway, our reference angle is pi over 3. Now, we are looking to find the tangent of 5 pi over 3. But that equals, now, here's the thing. We are in quadrant 4. In quadrant 4, the tangent is negative. So this is tangent of 5 pi over 3 equals negative tangent of pi over 3. Okay? Now, what's pi over 3 in degrees? 60. If you guys remember our 30, 60, 90 triangle, 30, 60, 90. We had 1, radical 3, and 2. Okay? Tangent of 60, because that's what pi over 3 is. Opposite over adjacent is radical 3. Well, since it's in quadrant 4, it's negative radical 3. So what we're doing, guys, is if you're not using a calculator, okay, you're not finding the tangent of 5 pi over 3. What you're really finding is the tangent of the reference angle. Okay? Because that value, that ratio is the same as the original problem. Okay? Hopefully that makes sense. Now, let's talk about the last one. Okay? These videos are lengthy. I apologize, but I want to make sure I try to explain as clear as I can, okay, what or how to do these problems to try to avoid lots of questions. All right, so I apologize for the length of the videos. All right, last one. Okay, secant of negative 3 pi over 4. Now, it's a negative angle. Okay, it's a negative angle. So negative 3/4. So we have to go clockwise. Whoops. I don't know what that guy's doing. All right. Now 3/4 is just short of 1 pi. Okay. So we stop short of the x-axis. Okay. Now our question is, what is the reference angle? Well, how many pi over 4s does it take to get to 4 pi? But in this case, pi is 4 pi over 4. Well, it's only 1 pi over 4. Okay. Now, here's the deal. Secant is just 1 over cosine. Okay. Cosine in the third quadrant, cosine is negative. Okay. So this is going to be negative secant of pi over 4. Okay. Which really is negative 1 over the cosine of pi over 4. Okay, if you want to put it in terms of cosine. Now, what's pi over 4 in degrees? Hopefully you said it already. 45. 45, 45, 90. We talked about this. Okay? Alright. So, the cosine of pi over 4 is radical 2 over 2. Now, when we apply that to this, negative 1 over radical 2 over 2. Okay, well that's just the reciprocal. I ran out of room, sorry. Okay, so our final answer is negative radical 2. Okay, because all we're doing is we're taking the reciprocal of this. Okay, we're just taking the reciprocal. And that, when you do the math, and I don't have a lot of room, so alright, if you took the reciprocal, you get 2 over radical 2, multiply top and bottom by radical 2. Here, let me get rid of this. As you can see, I have no room. I have 2 radical 2 over 2, but the 2's cancel, and that leaves me with radical 2. Since we're in quadrant 3, the negative goes there. Alright, now, quadrantal angles. Quadrantal angles, basically, the terminal side lands on an axis, x or y. Okay, so for the sine of negative 270, 90, 180, 270. So it ends on the positive y-axis. Okay. Now, what point could we say is there? Okay. All right. We can choose really any y we want, but to keep things simple, that point is 0, 1. Okay. And like I said before, sine would be the y-coordinate. So the sine of negative 270 would just be 1. Okay. All right. Guys, your answers are either going to be 0, 1, or negative 1. It's going to be one of those three. Okay. 0, 1, negative 1 for the quadrantals. Now, tangent of 3 pi. Okay. Tangent of 3 pi. Okay. 1 pi, 2 pi, 3 pi. So I end up there. Okay. Now again, for simplicity's sake, we'll say that that point is negative 1, 0. One thing you want to remember, tangent equals sine divided by cosine. So in this instance, it's 0 divided by negative 1. Okay? And, well, we know that's 0. So tangent of 3 pi is 0. Okay? Now, secant of 11 pi over 2. Now, 11 halves is 5.5. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi and a half. So it ends up right there. Okay? And again, for simplicity's sake, okay, we'll call this point for simplicity's sake, we'll call this point 0, -1. Okay? Now, the cosine of 11 pi over 2 is 0. Okay? It's 0. Now, secant of 11 pi over 2 equals 1 over the cosine of 11 pi over 2. Well, that's 1 over 0. So the secant of 11 pi over 2 is undefined. Okay? Because we had to do 1 divided by cosine of 11 pi over 2. Well, we just figured out that that's 0. Now, some of you may be asking the question, how are you getting 0, 1? How are you getting -1, 0? How are you getting 0, -1? Like those seem like random numbers. Well, first of all, if you land on an axis, one of the numbers is going to be 0. Okay? And for simplicity's sake, we're just using ones. It's just easier that way. Okay? Now, you're using one trig ratio to find the others. Okay, so it says to find cosine and tangent by using the given information to construct a reference triangle. Okay? Now, first one says the sine of theta is 3 over 7 and tangent theta is less than 0. So what that means is the tangent is negative. Now, when I draw my picture here, now, where's tangent negative? Well, tangent's negative in the second quadrant, and it's negative in the fourth quadrant. But the sine is positive. So, let me see here. We're going to make our reference triangle right there. Here's theta, opposite over hypotenuse. Okay. Now, we have to find out the length of the third side. Okay? So we have to do Pythagorean Theorem. So x squared plus 3 squared equals 7 squared. So x squared equals 40. X is radical 40, which breaks down to 2 radical 10. Now, here's the thing. In the second quadrant, x is negative. So it's negative 2 radical 10. Okay? So, now, the cosine of theta is adjacent over hypotenuse. And the tangent, okay, the tangent is opposite over adjacent. Okay? Now, the tangent is negative. It said that in the problem. Well, it's going to be negative here in our answer, which is good. That's what we want. Here's the only issue. We have to get rid of the radical on the bottom. So we have to multiply by radical 10. Notice I don't multiply by the -2. The -2 is fine. It's okay to be there. The radical 10 is what we want to get rid of. So I get 3 radical 10 over -2 times 10. Well, if I just clean this up, it's -3 radical 10 over 20. Sorry, that's a little messy. It should be a 20 on the bottom. Okay? So there's your reference triangle. Now again, the key is understanding which quadrant you're going to wind up in. Okay? Now, I'm going to erase this. Ugh. Wish I could just circle this whole thing, kind of like the smartboard. Just kind of do it that way, but I can't. So here I am, erasing and wasting time. Like I said, guys, I really do apologize for the length of the video, okay? But hopefully this will avoid questions and... So my video randomly paused. So I'm not sure where we left off, but here's the unit circle. Cosine and sine are the x and y's, okay? Tangent, sine divided by cosine. You have to know that, okay? Use it to do your homework problems, but when you get to quizzes and tests, you're going to have to know the different points of the unit circle and what angles those points refer to, okay?